So in this case, we are going to consider our typical exam, which is for our mathematics grade 11, paper 1, November 2023 exam that we are going to consider, which is very, very important as you are to revise towards your examinations. It's just unfortunate that we couldn't manage to work out our topics for term 4. But we have some of our term 3 and term 2 topics that we had together. So just use that and other revisions that you have from other channels that are there on YouTube so that you can learn other topics as you prepare for your exams that are ahead of time. So this is a 3-hour paper, 150 marks. Let us see what we had and how are we supposed to attempt these typical questions. Make sure that you go through your instructions and the information. Mostly, it is important that your answers should be given to 2 decimal places unless stated otherwise. So like I said, make sure that you go through your instructions. So I'm not going to waste time. I'm just going to quickly rush through our questions. Pick out what is important as you are doing your revisions. On question number 1, you are given 1.1 that was given k is equal to this expression that we are given there. Then on 1.11, we are given to show that k is rational if p is equal to 3. A rational number, remember, it is the one that you can express in the form of a over b, where a and b are integers. These are integers that you're talking about, and b cannot be equal to 0. So if we can have it in that form, that means we're having a rational number. So it was a simple substitution that you were simply going to need in this case. You are simply going to substitute the value of p that you're given in place of what? In place of p. There we are given a p, there we've got a p. So that is the square root of what? Of 5 over that's 3 plus 2. Remember, everything is being affected by the square root. Then plus, this is separate. This part is not under the square root, is separate. P is what? Is 3. Remember, your P is 3. So that is 3 over 3. So simplifying this, you can even use your calculator at once. But that was going to be 3 plus 2, which is 5. So you've got 5 over 5, which is a 1. And the square root of a 1 is a 1. So that's 1 plus, this was going to give us a 1 also. So adding these two, that was going to be 1 plus 1, which is 2. So is 2 a number that can be written in this form of a over b, where these are integers? Yes, because these can be written as 2 over a 1. We haven't changed anything. Every number can be written as or is over 1. 10 is same as 10 over 1. 5 is same as 5 over 1. We haven't changed anything. So that's a rational number because these are integers, a and b. So this is an integer. All right, 1.12, for which value or values of p will k be real? So for which value, or they can be values of what? Of p. For these to be real, that means we must be able to simplify. Remember, real numbers, guys. Real numbers, these are numbers that we can evaluate these numbers from our calculator, this and that. But if something is not real, let's just say square root of -4. This is not real. Square root of a number like a 0. Can we obtain square root of a 0, guys? Like, yes, we understand that. But if we have a number like a 1 over a 0, like a 2, or the moment that you are given such numbers, the square root of 7 over is correct. What about 7 over 0 and this number on its own? What does it mean? What is this? It's equivalent. Any number, once you divide, once the denominator is a 0 like this, guys, we cannot simplify that. 7 over a 0 cannot be simplified. So therefore, even the square root cannot be simplified. Let's consider the negative numbers, square root of -3. Can we simplify this? Even our calculator cannot simplify this. So working with the square root, we can see that, all right? Let's get to our calculator so that we can see what I'm trying to say. We are talking about numbers such as the square root of a -3. See that? Maths error. We cannot simplify that. Square root of, and now the moment we say maybe 5 over a 0 like this, all right? 5 over a 0 like this, look, cannot be simplified. What about square root of a 0? Okay, the number on its own, that one is a 0. Starting from there, square root of 1, we can simplify that. Square root of 2, we can simplify that. You can have the answers. So we can see that starting from the 0 going up, these numbers can be simplified. But the moment that this here, our denominator, which is the part that is going to affect everything, because that's where a P is. So the effect is there for this to be real. Guys, so to be real, anything like we can simplify square root of 2, square root of 3, square root. Those are real terms. We are not just talking about whole numbers. So in this case, you're going to concentrate on this part of the square root. Why not focusing on this part where P is on the numerator, guys? P over 3. No matter any value that you put here, you're going to have an exact value. You're going to have a real number from there. Think of any number. You put a -1, you put a 3, and nothing. There's no effect there because it's in the numerator. We do not have a limit when it is in the numerator, but the denominator is the one that we are affected because in the denominator, we cannot have a condition of k over 0 because this approximates to infinity. So we are going to concentrate on that to say our denominator, this one under the square root, is the one that we are going to put our focus on. So meaning to say P plus 2, what is it supposed to be in order for us to get what? In order for us to get a square root there. In order for us to be able to evaluate that square root, what are we supposed to have under that denominator? The number there is not supposed to be equal to 0. It's supposed to be bigger than a 0. Okay, this is what I'm trying to say, guys. When I'm saying the P plus 2, it represents the whole denominator. Just put any number there. This is the whole denominator, 5 over a certain number that you put here. All right? Plus a certain number over what? Over 3. Like I said here, there is no effect whether you put a negative, whatever that you put, it is not going to affect our P. But because of this part of the denominator here, guys, here, that we have, if we choose a number, let's say we put a certain number here, and we get a positive, we can simplify this, okay? Let me get you back to your calculator. We just put any positive so that you understand, because if you wonder, where is it coming from? We just need any positive value, okay? Let's just say square root of 5 over any positive value, maybe a 9, okay? We can see that we've got an answer there. That's an answer. That's a real number. It's an answer that we have. But let's put a negative. In that denominator there, we put a -9 like this. Look, math error. Meaning to say we cannot simplify because of having what? A negative. So the denominator, it is affecting, to say the negative that we see affects everything in that square root. So we cannot have it as a negative. So therefore it must be greater than 0, meaning to say it must be what? A positive value. It must be a positive value. So what is going to be the value of P from there? We can solve. So P, take the -2 to the other side. It is going to be greater than a -2. So meaning to say, in order for us to simplify this, our P is supposed to be bigger than -2. Why not saying P is supposed to be greater than or equal to -2? Why not putting the equal to? Because you might be asking, why not having an equal to? If you put a -2, it means your denominator is now having a 0. That's where you have got a number such as 5 over 0. Remember, you cannot simplify this. Okay, let me get back to your calculator so that we conclude this, guys. We're not supposed to take this much time on this question. But anyways, let's see. The square root of 5 over like this, you put a 0 like this. All right. Whatever that you're going to add, we do not care about what you're going to, we just need this part of the square root to see that it cannot be simplified. So that is, we cannot have our answer being equal to what? Being equal to -2. It can only be greater than -2. So the answer there was supposed to be P, greater than -2. Let's see another question where we are being asked to solve for X. This is an equation and you're being asked correct to 2 decimal places. Once you're given this instruction, know that they want you to apply your quadratic formula, or you can use the completing of the square method. All right, so let's see what we are given there. That's 1.21. We have got 3x squared. So definitely, guys, we know the format of our quadratic equation. Ax squared plus bx plus c is equal to 0. One side must be equal to 0. So we need to take all these terms to the other side of the equation. The 4x to the other side, it becomes a minus. All right, the 2 to the other side, it also becomes a minus. So that's equal to 0. Use your quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a, where we understand from this format, a is the part affecting x squared. So this is our a, which is a 3. B, the coefficient of x, which is a -4. And our c is the constant, which is what? A -2. So our c is -2. So let us just substitute into the formula. So x is equal to minus b, which is, like I said, from this, our b is what? -4. So that's a -4 plus or minus the square root of b squared. That's -4 squared. -4 times a, which is 3. Then you're going to multiply to c, which is a -2. Everything over 2 times a, which is 2 times 3. So you are going to simplify this to obtain the x values. A minus and a minus, which is going to give us a plus. So that's a 4 plus or minus. So we are going to have the square root of, you simplify the whole of this part that is under the square root. So you must simplify the whole of the part under the square root. That was going to give us a 40. This whole part under the square root. So that's everything over 2 times 6, 2 times 3, which is 6. So let us simplify this. We can just use our calculator direct on this part. And as you are told to 2 decimal places, you can even fix your calculator to 2 decimal places. All right, so this is what I'm having here. 4 plus, I'm going to start with a plus. All right, so we have got the square root of 14. Everything over 6. All right, so that was going to give us, press this SD. That's 1,72. You can even use your calculator, shift, set up, then fix to 2 decimal places. Press this 6 here to fix. So that's to 2 decimal places, you press 2. So as you can see, your answer is being rounded to 2 decimal places. That's 1,72. So that is it. Or the other x, if we are to simplify from this other side, you're going to have a negative there, which is negative 0.39. So that's negative 0.39. So these are the 2 possible values of x that you're going to obtain from this equation, from our quadratic equation as we had. So 2 marks. Why 2 marks, guys? All right. Anyways, under examined, if it is like that, you have to consider it that way. You're not supposed to assume the marks, but basically it's supposed to be 4 marks or 3 marks, something like that. Because if an inequality has got 4 marks, this is also supposed to have the same number of marks for them. Okay, anyways, it was 2 marks. 1.22, this is an inequality that you're given. As they are saying x squared plus 10x is greater than. So we can take this negative 21 to the other side, it becomes a positive. So that's greater than 0 there. So that's a quadratic inequality that we have where we can solve finding of the critical values. So we can actually, as we are to consider the critical values, we solve that as an equation. So by factorization, you can just have your two brackets, equate these to zeros. Now it's an equation. The moment I'm finding critical values, I'm going to write is equal to here. All right. So please be careful on that. So this is it. This is a quadratic, and the highest x on the highest exponent there, which is of 2, the quadratic part there, which is 2. The coefficient of x squared is 1. So we can simply have two brackets that we are going to use an x here and another x here. So let's focus with our constant term, which is the negative 21. What are the factors of negative 21, which will add up to a positive 10? So we need two numbers. You multiply two numbers, you get a positive 21. So that's 7 and 3. You add, you obtain a 10. So that's a 7 and a 3. Okay. So using these numbers, we can now determine the x values, meaning to say x is equal to what? A 7 to the other side. It was going to be a negative 7. Or x is equal to 3 to the other side. It was going to be a minus 3. With these values, we can now determine the exact solution depending with the method that you're going to use. If you're using the graphical concept, x squared, the coefficient of x squared is 1, which is a positive. So this is going to be a smiley shape like this. You're having two solutions at minus 7 and at minus 3. The smallest value, that's a minus 7. Remember, minus 3 is bigger than minus 7. So minus 3 is going to be this side. So where are we going to consider the solutions? Where this function, the wall of this function that we are given here, the wall of this function is bigger than 0, is greater than 0. This function is greater than 0. That means it is above the x-axis. Remember, in the x-axis, that's where y is equal to 0. But we need above, that's on top. So on top, the solutions will be this side, and the other solution will be this side. All right, so that's x is what to minus 7. X is less than a minus 7, or to this side, x is greater than a minus 3. So these are the possible values of x that you can talk about, where these are real numbers that you are referring to the x values. All right, let's consider another question, which is 1.23. That was to solve again. This time it's an equation that we are given, considering that we have got the square root. So remember, we have to remove that square root. All right, so that's 1.23. We have got the square root of x squared minus 5 being equal to 2 square root of x. So looking into this question, we can see that we have got a single term and we also have a single term here. So we can introduce the square to remove the square root. So square both sides, square both sides. The moment you square, you are removing this square root, meaning to say we are going to remain with what? X squared minus 5. So x squared minus 5 is equal to, we square this, 2 raised to the exponent of 2. That is a 4. The square root of x, when being raised to the exponent of 2, it's going to be x. All right, remember, guys, from your laws of exponents, that's equal to x. You can even write it this as x to the exponent of half raised to the exponent of 2. That's a half times a 2, which is what? Which is a 1. So that's simply x. All right. Square root of x times the square root of x is what? Is x. So as you can see, we are now having a normal equation, which is a quadratic equation, the highest exponent being 2. So remember the format, guys. One of the sides must be equal to 0. So take the 4x to the other side. That will be x squared minus 4x minus 5 is equal to 0, like that. So now we can solve our equation. Two brackets that we can have, as we can see, just like the previous case, guys, the coefficient of x squared is 1. So you're going to have an x here, another x here. So let's focus with our constant, which is negative 5, to give us a minus 4. Which factors are we going to use? You multiply two numbers, you get a minus 5. But you add the two numbers, you get what? A negative 4. So that's negative 5 and 1. If you multiply this, that's a minus 5. If you add, that's a minus 4. All right, 5 and minus 1 if you add, you are going to get a positive 4. So this cannot work because if you add here, you're going to get a positive 4. So we need this one, the -5 and what? And the positive 1. So meaning to say x was going to be what? -5 to the other side. That's a positive 5. Or x was going to be 1 on the other side, was going to be a -1. So these are the two possible solutions that you're obtaining by calculation, but we must verify to see which one is the exact solution by substituting the values of x that we determined. All right, so let's substitute. If x is 5 here, what are you going to have? 5 squared minus 5 under the square root. You can even use your calculator, guys. This is just a mere substitution that you are just doing here. So, okay, let's have our calculator. Let's have our calculator here. That's the square root of, remember, this was the square root of x squared. So that's 5 squared minus a 5. So you're going to obtain 2 square root of 5. So that's 2 square root of 5 is equal to 2 square root of x. Remember, our x is what? Our x is 5. So these two, as you can see, they are equal. So x is equal to what? To 5. Let's have a -1. We substitute a -1 this time. So that's -1 squared here. So we are going to have a -1 squared, -1 squared, -5. So as you can see, that it cannot be simplified. We cannot simplify that, but it was going to give us square root of a -4. As you can see, this cannot be simplified. So that's, we cannot use that solution in this case. So x cannot be equal to -1, but it can be what? It can only be a 5. All right, so that's it, guys. We have our solution there. On 1.24, solving this equation, we are back to our exponential equations. That's 1.24. So if you're to consider, they were given 3 to the exponent of x plus 1 plus 3 to the exponent of x minus 1 is equal to 10 over 9. We dealt with our exponents, guys, to an extent that we must be able to understand these typical questions, guys, as we had our exponents. Remember, I said you can separate these exponents that you are given. 3 to the exponent of x is common. Here it is common. So you can separate that easily. This is same as 3 to the exponent of x times 3 to the exponent of 1. It's a positive. Just use it as 1. Plus, you separate this 3 to the exponent of x times, just take as it is, but with a minus there, 3 to the exponent of -1. This is equal to what? 10 over 9. So as we have our numbers, we can see that 3 to the exponent of x is common in these two. There's a 3 to the exponent of x, a 3 to the exponent of x, which we can factor out because it is common. So we can factor out that. So removing or factoring out 3 to the exponent of x, what are you going to remain with here? 3 to the exponent of 1. If we remove 3 to the exponent of x here, we're going to remain with what? 3 to the exponent of -1, which is equal to 10 over what? 10 over 9. So that's it. We can simplify this, or you can to this side of the equation. So you can simply take your calculator, guys, instead of, yes, you can simplify that. I'm not saying it is wrong. No. I'm not saying that. But you can even use your calculator like this. This is 10 over a 9. That's 10 over 9 like this. All right. You're going to divide by this bracket. So remember, there's a bracket that you're given there. So let's just have it in bracket 3. To the exponent of 1 is just same as 3, guys. All right. Divided 3 to the exponent of a -1 as it is like that. So a calculator can simplify that. That was gonna give us 100 over 27. All right, let me put a bracket here, guys. Remember, these calculators also sometimes they can just misbehave in terms of calculations there. So let's put, okay, this one is gonna close up everything. No, we need this bracket to be here, not to close up everything. Okay, let me put this, guys. You have a bracket first, all right? 10 over 9, you have a bracket first like this. Okay, then divide to this one, to this bracket, 3 to the exponent of 1 plus 3 to the exponent of a -1, like that. All right, so that was going to give us 1 over 3. So make sure that you use your calculator properly there. So you can simplify that bracket. Like I said, if you want, guys, we're going to have something like this. If you just wanted to simplify this part of the bracket, it was just going to be 10 over 3. So this whole part that we are talking about here is 10 over 3. Then you divide by 10 over 3 both sides. Still, you're going to obtain that 1 over 3. Okay, so that's one and the same thing. So with this, we can now equate. Before that, we can see that we have this 3 to the exponent of x, 1 over 3 can be written as 3 to the exponent of -1. And knowing that the bases here are the same, we can equate our exponents. So therefore, our x was going to be equal to what? A -1 from that. So you have to be careful in your presentations. You must be very, very careful in your presentations. All right, let's consider another question on question number 1.3. Given that x plus y is 2, that's an equation that you are given there. X plus y is equal to 2. Solve for x and y. Another equation, y plus 1 is equal to -3 over x minus 1. So you're given two equations and you're asked to solve for x and y simultaneously. All right, so let's consider the substitution method. This is our equation 1. This is our equation 2. So it depends with which part are you gonna work with? Is it equation 1? Is it equation 2? So it was gonna be easier working with equation 1. We can make x the subject. We can make y the subject there. Any part that you want. It was up to you. Which one do you want to make the subject? All right, so as for me, I'm just going to make x the subject. All right, so that's in this case from equation 1. So I'm using substitution method. So from equation 1, I'm going to make x the subject. Make x the subject of the formula. All right, meaning to say x will be equal to what? We have to take y to the other side, meaning to say it will be a negative there. So that's 2 minus y. So we now have another equation that we have formulated, which we can call equation 3. All right. So since I made x the subject from equation 1, I'm going to substitute in equation 2. Whatever that I'm having now must be substituted in equation 2. So you substitute in the other equation. So in equation 2, so substitute minus y like this. It is going to be y plus 1 is equal to -3. So that's a -3 like this over in place of x, where we can see our x, where we have our x, 2 minus y. The whole of this part that we see here, which is 2 minus y in place of x. So that's 2 minus y like this in place of x. But we're seeing that there's a -1 that is remaining, this one. So we are supposed to subtract also that. So there is a -1 that we are having there. All right, so that's an equation which is just having y as we can see. So let's try to work out and solve for y as we can see. This is the same as over 1. We can simplify further. Y plus 1 over 1 is equal to -3 over 1 here. That's 2 minus 1, which is 1. So that's 1. To remove the fractions that we are having there, that's y plus 1 into the bracket of 1 minus y is equal to 1 times -3, which is -3. All right, so in this case, we can consider expanding of the brackets, all right, by the FOIL method. We can expand. Y multiplies everything. That's y times 1. Then y times minus y there. Okay, so y times 1. That's y. Y times minus y there. That's minus y squared. You are done with the y there. You move on to 1. 1 times 1. 1 times minus y. All right, so 1 times 1. That's a 1. 1 times minus y there. That's a minus y, which is equal to a -3. All right, remember you're still solving, still trying to take our terms to one side so that we have a normal quadratic. But with that, you can see that these two was going to cancel. This is 1y and this is -1. So this was going to cancel. And thus we're going to remain with minus y squared plus 1 is equal to -3. All right. Since we just have a y squared, we do not have any other part of y like y squared plus 3y, this and that, where you form a quadratic, that quadratic equation, one side must be equal to 0. In this case, it's just y squared. So on transposing, you can even simply transpose the 1 to the other side of the equation. So it becomes a minus there. So that's minus y squared is equal to minus 3 minus 1, which is a minus 4. So as we can see, you can divide by y and y, that's y squared is equal to 4. So if y squared is equal to 4, what about the value of y? Introduce the square root to remove what? The square. So that's obtaining the two possible values of y. Remember that the square root of any number is a plus or a minus. So that's plus or minus 2, meaning to say y can be plus 2 or it can be a minus 2. There are two possible values of y. But remember that we said x is equal to what? X is equal to 2 minus y. Remember that from equation 3 where we made x the subject. So we can take that now into our advantage to say, since x is given as 2 minus y, therefore we can have the possible values of x from there. If y is a positive 2, therefore x is going to be 2 minus a 2. Y is positive 2. So x was going to be what? A 0. So meaning to say when y is 2, this is happening when y is what? When y is 2. On a condition that when y is equal to a negative 2, our x value was going to be what? 2 minus the value of y. The y value that we have is a minus. So it's a minus, minus. So it was going to be minus, minus. So x was going to be what? That's a plus. And 2 plus 2, that's a 4. So meaning to say when y is minus 2, x is what? X is a positive 4. That is what it means. So these are the y from there. All right. So that was it there for 5 marks. And on another question, hence or otherwise. So in most cases, I prefer to work with the hence. Hence, it's continue from what you have just determined. Determine the value of 1 over x plus 1 over y. Determine the value of 1 over x plus 1 over y from this information that we are given. 1 over x plus 1 over y. How can we simplify this? We just have to substitute what we are given. X gave us what? X gave us a 0. But look, if you substitute a 0 here, we cannot simply remember the denominator cannot be equal to 0. So meaning to say this cannot work, the first combination. We move on to the second combination. Remember, when y is 2x is what? X is 4. So this is a proper combination. X, the denominator can be what? Can be 4. Can be a whole number, but the denominator cannot be a 0. Remember, guys, we've been talking about this. So it's going to be 1 over x, which is 1 over 4, plus 1 over y, which is, our y is what? Minus 2. So guys, this is just a straightforward substitution on your calculator as it is. That was going to give you minus 1 over 4. Do not waste much of your time there. Just use your calculator direct. So this is how these questions sometimes might be given as. Then on 1.2, you're given 2mx squared minus this, all right? Where m is not equal to 0, determine the value or values of m for which the equation has real roots on 1.41. For this equation to have real roots, we do understand this is a normal quadratic. We are talking about the quadratic roots. Those roots of from our quadratic equation, the discriminant from our delta must be greater than or equal to 0 for any real root. It can be real and equal. It can be real and rational. It can be real. As long as it's a real root, we have to be greater than or equal to 0 from a quadratic where this discriminant, our delta, is representing what? B squared minus 4AC. So from there, remember from our quadratic equation, the format, guys, I talked about this, ax squared plus bx plus c must be equal to 0. So this whole part, the coefficient of x squared represents our a, then our b is this part here minus into the whole of this bracket, that's our b, and our C is the constant, the m plus 1. The m plus 1 as it is. So meaning to say we could have calculated this delta, which is our discriminant. B, like I said, the whole part of B, that's minus into m minus 2 like this, but it must be squared. This is b squared. All right, minus 4a. Our a is what? 2m times c, the constant part where we do not have x. So where we do not have x, that's this part of what? M plus 1. So that's m plus a 1 like this. So this is the part of your discriminant. So that was going to give us a negative when raised to the exponent of 2. It becomes what? A positive. So meaning to say you are going to remain with the m minus 2 squared. So remember, guys, from your identities, this squared, this m minus 2 squared is going to be what? M squared minus 4m plus 4. All right. First term, this and that. Remember, guys, from your expansion of brackets. All right. Then here and 2. So if you multiply these two, you're going to get a negative 8m. All right, then you expand by that negative 8m into this bracket of m plus 1. So that's minus 8m times m, which is minus 8m squared. Minus 8m times 1, which is minus 8m. All right, so this is where you are. And at this stage, we can see that we have got like terms to be considered. All right, let's start to the part of m squared. And this minus 8m squared. These are like terms. The part where we have got the m here and the minus 8m, these are also like terms. So meaning to say the first part was going to be what? That's 1 minus 8, which is minus 7. That's minus 7m squared. Then there's a minus 4m and a minus 8m. Minus 4 minus 8, that's minus 12. Then the 4 is remaining as it is like that. So this is what you're going to have as your discriminant, the part of your delta. But you're saying it must be greater than or equal to 0. So meaning to say minus 7m squared minus 12m greater than, must be greater than or equal to 0. It's an inequality that you have. It's an inequality, this one. So you are solving an inequality. All right, let's get rid of the negative that is affecting our m squared. There's a negative there. We can simply divide. Remember to avoid this negative. Divide by negative 1, each and every term by negative 1. Knowing the effects of dividing by this negative, that the moment you divide by a negative, what is going to happen? It is going to affect our inequality sign because you divided by a negative. The inequality sign is going to reverse. It changes. Inequality sign reverses. Inequality sign reverses. So if it is like this, it means our inequality has changed. There was an inequality that you're solving before, that you had, that you're supposed to solve this one. But now it has changed. The inequality sign has changed. Take note. This is what you're now solving. So as we do understand every inequality that you're going to solve, you're going to be working with the critical values. Where you solve for the letter that you're given, we are solving for m. So critical values, you're going to use your factorization method, whatever that you're going to use, or you're going to use a quadratic formula. So most of you guys, once the coefficient of m squared is no longer a 1 like this, it becomes a challenge. So use your quadratic formula if it is like that. Just use your quadratic formula. M is equal to what? Minus b. Remember, this is your a, this is your b, this is your c. So it's minus b, which is minus 12, plus or minus the square root of b squared. That's 12 squared, minus 4 times a, which is 7, times c, which is minus 4. Everything over 2a. Everything over 2 times a, which is 2 times 7. So there we are going to obtain the possible values of m, guys. Okay, that's a minus 12 plus or minus the square root of, simplify these numbers under the square root. That was going to give us 256. So you can simplify this over 14. Simplify this separately. You're going to obtain two possible values of m. A 2 over 7 for a positive and an m which is a minus 2. But remember, like I was saying, the new equation that you're now having, that you're solving, like I said, you're now solving, I mean, the new inequality that you're solving, divided by negative e, we now have a new inequality. So if we are to analyze the solutions now, the coefficient of m squared there of that quadratic, it's a positive, as we can see, meaning to say it is going to give us a smiley shape like this. Okay, where this is our minus 2, the smaller value, and the positive one this side, 2 over 7. These are the x values. So where is it that this function, the whole of this function is less than, like I said, we are now working with this new inequality. So we need where it is less than or equal to 0. Less than, remember, this is y is equal to 0. So less than, that's down here. Below the x-axis, the line of the x-axis below that. So it's within this region. So that's from minus 2 up to what? Up to 2 over 7. So therefore, our m was going to be greater than or equal to, because there is an equal to there on our presentation. So you must put that equal to. So it's greater than or equal to minus 2, but less than or equal to what? 2 over 7. So that is how it was going to be like at the end. So these are some of your typical questions, guys. You just have to revise in as much as you can. Try to condition where two real values that are opposite in sign, if m is less, they are telling you that if m is what? Is less than 0. So on a condition like this, guys, when you are given two real roots that are opposite in sign, you work with the constant in that case. All right. So you work with the constant, your constant, which is this constant. Remember, we said our c is what? M plus 1. That is our constant. That constant c is supposed to be bigger than 0. So m must be greater than 0. M plus 1. This is our constant. So what is the value of m? Take the 1 to the other side, it becomes what? A minus. So m is greater than minus 1. But remember, we are told that if m is less than 0, so therefore we must have a solution that m is bigger than minus 1. It is greater than minus 1. But the same m that we are talking about is supposed to be less than what? It's supposed to be less than a 0 as an instruction that we are given. So that is what we had, guys, on our question number 1, which had a lot of marks. That was 33, which is, if under exam you can obtain these, you've obtained a lot of marks, of which you guys, you tend to leave these marks. I do not know why on this question number 1. Please, guys, do revise as much questions as you can. Remember, this is the final exam from what you had since term 1. You do not just work with term 3 and term 4, from what you had since term 1. All right. Anyways, 2.11 on question number 2, we were being asked to simplify without the use of a calculator. The calculator is not required here. So that's 2.11. Let's divide, guys. This can be divided, isn't it? 512 divided by 64. That's 8. Then there we are dividing. We can even use the laws of exponents. If we are dividing, we subtract. This is 3 minus 3. We subtract our exponents. So that's a plus. So 3 plus 3 is what? 6. So that's x to the exponent of 6 raised to the exponent of minus a third. That's minus a third that we are seeing there. All right, so that's another stage that we have simplified there. All right, since there's an exponent, let's try to have this 8 raised to a certain exponent, just like x to the exponent of. So what can we do with 8? 8 is times x to the exponent of 6. This whole bracket being raised to the exponent of minus 1 over 3. Remember, from your laws of exponents, if you are given ab to the exponent of m, a will be raised to the exponent of what you are given, the same as the x also. So meaning to say that's 2 to the exponent of 3 to the exponent of minus 1 over 3 times x to the exponent of 6 to the exponent of minus an exponent. X to the exponent of a to the exponent of b is the same as x to the exponent of what? AB, the product of A and B together. So just like that, you have to multiply exponent, multiply. 3 times minus 1 over 3, that's a minus 1. Okay. 6 times minus 1 over 3, that's a minus 2 from your calculator. So remember, from our negative exponents, x over x to the exponent of n. So meaning to say, that was going to give us 1 over 2 times 1 over x squared. All right. So we've got 1 over 2 and 1 over x squared. But this can be combined numerator to the numerator, which is what? Which is 2x squared. So this is what you're going to have. As you can see, this is in the simplest form. There's nothing that we can do, guys, at this stage. There's nothing that we can do at this stage. This is the simplest form that we can ever have. All right, let's consider and of. All right, as we can see, let me just try to make it here. This is x to the exponent of n plus 2 plus x to the exponent of n plus 1 minus x to the exponent of n minus x to the exponent of n minus 1 over x squared minus 1. There was something that was simply common here, x to the exponent of n being common. So you can play around that and factor it out. All right, so this is 2.12. So instead, we could have I'm just going to start by calculating, guys. Remember how you separate this, like what we had before, guys. X to the exponent of n times x to the exponent of 2 plus x to the exponent of n times x to the exponent of a 1 minus x to the exponent of n. There's nothing to be multiplied there. There we've got a negative 1, so it's minus x to the exponent of n times x to the exponent of minus 1, like this. So you're going to see that the x to the exponent of n is common. It is there, here. All right, that's we could have factored out here. We have it here. We have on this term. We have it here. We have it each and every term that we see there. X to the exponent of n is common, so you can factor it out. What are we going to remain it? On the first one, it's going to be x squared out, so it's just going to remain with a 1 minus x to the x simply means 1 over what? Simply means 1 over x, so you can even write it as 1 over x like this. Everything over x squared minus 1. All right, this is where we are, and we can see that we need the x squared minus 1, and we can see that here, x squared minus 1. So we can try to have that on its own because it can be factored out. So let's have it that way. Then we have to rearrange. So it's x squared minus 1. What are we remaining with? We are remaining with x and minus 1 over x. So we are remaining with the plus. X is what we are remaining with. If we collect our like terms, these two are going to remain. Everything over what? Everything over x squared minus 1. So as we can see, we cannot divide because we can see the x squared minus 1 because there's another term here. The only way that enables us to divide is something that is common. So can we obtain something that is common between these two? Let's try to simplify first. X minus 1 over x, this part. It is same as what? It is same as over 1, this one. So the LCD is x. Let's divide x divided by 1. That's x. And x times x is going to give us x squared. X and x, that's a 1. And 1 times 1 is going to be 1. So as you can see, we are going to have x squared minus 1. Over what? Over x. All right. So let's rewrite these guys and see how it was going to be like. X to the exponent of n. Into this bracket, we have got x squared minus 1. And this part, as we combined it, we combined, and this is what we got, plus x squared minus 1 over x. This is what we're obtaining. Everything that we are obtaining is going to be what? Over x squared minus 1. So looking into this, we can see that the x squared minus 1 is common and it can be factored out. This one, x squared minus 1 here, and factored out. Guys, this is same as over 1, this one. It is same as like it's over 1. So we can factor out the x squared minus 1 that we see here, this one. Just like how we factored x to the exponent of n. So it was going to be x to the minus 1. We can factor it out. The moment we factor it out, what are we going to remain with in this bracket? We are going to remain with 1 here over 1. And 1 over 1 is same as what? Is same as 1. Plus, if we factor it out, it's going to be 1 over what? Over x. So it was going to be 1 over x like this. Everything over what? Over x squared minus 1, which we can cancel now because it's a product multiplication. These two can now be divided, these two, they can now cancel. So meaning to say, our final answer was going to remain as x to the exponent of n into 1 plus 1 over x like this. All right, so this is what you're going to have at the end. If you want to simplify further, you can simplify further from there. But if you check your memo from there, they just made a simple mistake from the simplification that they had in terms of the final answers. We can have this in different calculation, but I just want to correct the way that they did. They had a stage. If you check, if you're using maybe a memo in your revision, they had a stage like this: x to the exponent of n over x squared minus 1 plus x to the exponent of n. This is what they had. Me, I did not work it with this one. Everything over x squared minus 1. So the error there was here. If you factor, if you can see, x to the exponent of n is common. You factor it out at once. The same way that you factor out the x squared minus 1, they are factored out at once. So meaning to say we are going to remain with what in this first part? We have factored out everything, so that's a 1. What about here? You factor out this, you factor out this, everything over what? X squared minus 1, and this cancel. So they just made a mistake on canceling. They remained with x to the exponent of n, also having x to the exponent of n on another part. No, it cannot be like that. If you take it out of the bracket. All right, 2.13. You were given to simplify again. There's a square root and square root. You just have to figure out what is happening here. All right, so let's see, that's 2.13. We had a square root, and this square root was covering up a plus the square root of 2a minus 1. All right, so whatever that we have here must be multiplied to the square root of a minus the square root of 2a minus 1, like this. All right, so remember when you're dealing with your surds, this consider our surds. When we are multiplying the surds, they allow us to multiply the numbers under the square root from our laws. Square root of a times square root of b. Remember, I explained that it is the product of a and b under the square root. It allows us to do that. So since there is a square root, this one, the major square root, this one, the outer square root, this one, the outer square root, it allows us to multiply these numbers under that square root. So it is going to be the square root of a, this is the first part of our bracket as it is. So you can even just open a bracket there, a plus the square root of 2a minus 1. All right, so this is supposed to be multiplied to the other part, which is our b, this one, under the square root, which is a minus the, it was going to be like everything under the square root. Everything is under the square root. So as we are to consider these terms that are under the square root, we can see that the terms or that we have, they're exactly the same, or these brackets. This is a, this is a, all right? There we have got 2a minus 1 under the square root. There we have got 2a minus 1 under the square root. The only difference that we see is here, the plus and the minus. What is it from? Where was this taken from? Where one is a plus, another one is a minus. From our difference of two squares, a squared minus b squared, remember, is the one that gave us what? For you to have this bracket, it means before these numbers were being squared, the first term was being squared. It was a squared before, minus b squared, minus, what is our b? This other part that is remaining there, the 2a minus 1 under the square root. It was like this, under the square root like this, being squared. That's the part of what? Of a squared minus b squared. So this is our a, this is our b, this is our a, this is our b. So if it was like this before, then what does it mean? Means we can, now it can be simplified in an easier way because we can simplify this, guys. A squared remains as a squared minus, remember I talked about this when we had the square root of x, it was square root of x squared, and we said it's x. So it's the same thing, the square root when being raised to the power of 2, it is simply what? Neutralizing, removing the square root. So it will be minus what? This part under the square root as it is, which is the 2a minus 1. We just have to remove the square root. All right. So the bracket there is for the negative. The negative there is supposed to affect everything that is inside. So do not forget that bracket in your simplification, guys. All right. So let's simplify, and a squared minus distribute in this bracket. It is the same as we've got a minus 1. So it's minus 1 times a, which is minus 2a, minus 1 times minus 1, which is a plus 1. So if a squared, if we have this, let's try to factorize, all right? So you're going to factorize. Remember, the equivalent of x squared there is 1. So from our factorization method, we're going to just have 2 brackets. That's a here, another a here. Considering the constant, which is 1, what are the factors of 1? But when you add the factors, you must get a negative 2. 1 and 1, these are factors of 1. But if you add, you're going to get a positive 2. To get a minus 2, we must have minus 1 and minus 1. Minus 1 times minus 1, that's a positive 1, 2. So we need minus 1, minus 1. Guys, if we have x times x and we say it's x squared, what about a minus 1 into a minus 1? It is the same thing. It is the same thing as we are writing this as what? A minus 1 squared. Just like write x squared. So there it is the same as we've got what? A minus 1 squared. And remember what I said before, the square root of x squared is what? It's x. So the square root of a minus 1 squared is simply what? Removing the square that we are given. So we remain with what? With the a minus 1. All right. So this was simply going to be equal to a minus 1. The square root and the square, they neutralize the 2 that you are seeing there. So meaning to say, we're just going to remain with what is under the square that we are seeing there without any effect. So questions can be like this. They'll be testing you guys. They want you to fill under the same sets that we are having. Another question was given this, and determine without the use of a calculator the values of x, y, and z from this equator sets. So as you can see, guys, sets can form equations. All right, sets can actually form equations. All right, so it was given as 1 minus the square root of 2 into the bracket of x plus y square to minus 3 plus the square root of 2. And you need to find or to calculate the value of x, y, and z. This is where we have x, y, and z, as you can see, guys. So let's just remain with this and get rid of this other bracket that we see. Just have to divide by this bracket, 1 minus square root of 2, 1 minus square root of 2. So this can simply cancel. So you remain with x plus y square root of z. So this here, it's a format, guys, that you are writing your answers 2 plus 3 square root of 5. It's a format. So x simply represents a number, y a number, z, and this is what they are simply trying to say. So you must simplify your right-hand side until you get simplified that, until you have that format. That's what they're simply trying to say. They're simply trying to say simplify that side until you obtain what? This format. So how do we go about it? Remember, rationalizing the denominator, introducing a negative becomes a positive on the part of the square root there. So it'll be 1 plus the square root of 2 over 1 plus the square root of 2. All right, you introduce a negative, so this becomes a positive. So as we can see, guys, we're going to multiply the numerators together, the denominators together. So that's x plus y square root of z is equal to negative 3 multiplies a 1 there. That will be negative 3. Negative 3 times square root of 2. That's negative 3 square root of 2. Square root of 2 multiplies a 1. So that is going to be square root of 2. 1 square root of 2. Square root of 2 times square root of 2. Remember, guys, what I talked about, square root of x times square root of x is x. So square root of 2 times square root of 2 is going to give us what? A 2. Everything over what? We do the same thing in the denominator. We multiply 1 times 1, which is 1. 1 times square root of 2, that's square root of 2. We are done with 1. We move on to the square root of 2. The square root of 2 multiplies 1. That's minus square root of 2. Square root of 2 times square root of 2, we are back to that same thing there. That's a minus 2. So meaning it is equal to, let's simplify the numerator, collecting of like terms, where we have got the like terms, the minus 3 and the 2 there was going to give us a single term. And also this part here, the square root of 2 part there, it was going to also give us a single value. All right, so let's see. What do we have there? Minus 3 plus 2, that's a minus 1. So that's minus 1. Minus 3, square root of 2 plus 1 square root of 2 simply means minus 3 plus 1. Collect the like terms in the denominator, 1 and a minus 2. 1 minus 2, that's minus 1. As we can see, guys, the square root of 2 and square root of 2 was going to cancel. These two are the same. So square root of 2 minus square root of 2 was going to give us what? Was going to give us a 0 there. So remain with the minus 1. We still not yet that the format, because we need this format, guys. So that's x plus y square root of z is equal to, you can divide each and every term. Remember that a plus b over c plus b over c. So you can separate the minus 1 and the minus 1 and this. So you can separate this as minus 1 over minus 1. Then you're going to have minus 2 square root of 2 over minus 1. So this was going to give us a positive. All right, minus minus, that's a positive also. So that's 2 square root of 2. So as we can see, guys, we are now at that exact format which is being represented on the left-hand side. Exactly what we see on the left-hand side. So therefore, x corresponds to what? We are just taking our values from there. Y is corresponding to what? Y is corresponding to 2. And the z, the number that is under the square root, our z is what? 2. As it is there. We are just taking our values as they are corresponding from what we solved. So exam, guys, exam is not an exercise. They are testing you from everything that you have learned. They want you to use the information, gather that information that you have done before, all of it. Answer these questions. All right, let's consider question number 3, where we are given 3.1. That's a pattern that you're given there. And on this pattern, we are given the tan sine of x, sine cos x. Explain how each term is found from the previous. All right, the first one is tan. The second one is sine. And we can see the third one, it's a product, sine times cos. So we're simply multiplying by cos. This is sine, now it's sine cos, all right? A tan to give us a sine, it was, remember, tan is set a cos x like this. This was going to cancel and we get what? A sine x. So in this case, each and every part that we see, it was simply being multiplied. The previous term was being multiplied by what? Cos. So here, the previous term multiply the previous. All right, that's the previous term by what? We are simply multiplying by the cosine of x. That's by cos x. Fourth term, T4 of the pattern. This is T1, T2, T3. So T4, we're just going to multiply by cos x, meaning to say it is going to be, it is going to be written as the sine of x. Cos of x and cos of x is going to give us what? Cos squared x. So that's it. So that's our fourth term. Then from this, given the pattern minus 1, 2, 5, 8, determine an expression of that and see what we have there. Let's start with the difference first. Do we have any common difference there? Term 1, term 2, term 3, T4, that's T1. That's 2 minus T1, which is a minus 1. All right, minus and minus, that's a plus. So that's going to be 3. There's a difference of 3. T3 minus T2, 5 minus 2. 5 minus 2, which is a 3. So as you can see, guys, there's a difference of 3, a difference of 3. That's a linear pattern. So therefore, Tn was supposed to be given in the form of A plus n minus 1 into D. We're in there. So meaning to say the first term A is minus 1 plus n minus 1 times D, the difference of 3, the difference there. So that's your Tn. Expand plus 3 times n, which is 3n, negative 3. So that's Tn is equal to 3n here. Collect the like terms, the negative 1 and the negative 3. All right. So there we have to consider like terms, negative 1, negative 3, which was going to give us a negative 4. So that's your Tn. So there are so many ways, guys, that you can actually use. You can use your grade 10 concept, your grade 9 concept. Remember, guys, it's up to you. Way that you understand so many ways of evaluating them. And after that, they want you to determine or to write which term of the pattern will be equal to 161. So in actual, we are given that Tn is 161. So what is the value of n? So it's just going to solve an equation when 3n minus 4 is equal to 161. So that's 3n is equal to what? Take the minus to the other side, it becomes a positive. That's 165. So simply divide by 3. By 3 both sides, that's determining the value of n. So n was going to be 55. That the value of n corresponding in order for us to obtain 161. That is what you needed. All right, still on your number patterns on question number 4, they wanted you to study this diagram. The first 3 figures in a pattern that Mary is investigating are shown. Fig 1 can see is 1 square. Then there are 4 dots. All right, there are 1, 2, 3, 4 squares. And the dots is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is just the pattern. So determine the total number of squares for figure 5. What is happening with the number of squares in each? Okay, the first one, the fig 1, the squares, we're talking about the squares, all right? We're talking of what? The squares that we see. It is only 1. There's 1 here. In fig 2, how many squares? 1, 2, 3, 4. There are 4 squares. In fig 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 squares. What is happening between the figure and the number of squares? The figure and the number of squares. 1, it's 1. 2, it's 4. 3, it's 9. As we can see, it is simply a matter of the figure that we are being given raised to the exponent of 2. If it is 1, 1 to the exponent of 2, that's a 1. If it is a 3, 3 to the exponent of 3, which is a 9. So for figure 5, our answer was simply going to be 5 squared, which is what? 25. Okay? So that's it. You just have to study, guys, what is happening. In fig 7, how many dots? In terms of the dots, what is happening in terms of the dots? Fig 1, there are 4 of them. 1, 2, 3, 4. There are 4 dots. Fig 2, there are 9 dots that we see here, times 4, which is 16. So it's like we still have the perfect square concept, but it is no longer corresponding. Remember, it was 1 squared giving us a 1, 2 squared a 4, 3 squared a 9. But it is 2 squared. So it's like this figure 1 is having 1 unit. Like it is having something like this, guys. Look what is happening. If this is 1, it is going to be 1 plus a 1. Figure 2 is going to be 2 plus 1 squared. If it is figure 3, it is going to be 3 plus 1 squared. Are we seeing what is happening? In order for it to have 4, 1 plus 1, which is 2. 2 squared, that is 4. Figure 3, 3 plus 1, which is 4. 4 squared, which is 16. That is the issue of the dots. So what about figure 7? It means 7 plus 1 squared. And what are you going to have? So you have to study, guys. Study that pattern, okay? So that's it. On 4.13, they want you to, considering the nth figure, show that an expression for the number, this one that we had, can be written as this. That's a quad. They are simply telling us that for this, in terms of the dots, it is a quadratic pattern that you are forming there. And it must be like that. All right, let's see. That's 4.13. Remember, we are dealing with of what? The number of dots. From the first figure, from the first one, there are 4. The second one, the dots, there are 9, 16, and so on. So it's going to be like a 5. up to the end where we do not even know where it is going to end. So let's find the differences first. Remember, quadratic, we must have the first difference and the second difference. All right, so that was going to be second term minus first term. We subtract, which was going to be 5. 16 minus 9, which is a 7. 25 minus 16, which is a 9. 36 minus 25, which is 11, and so on, depending on what you have. You find the second difference. Remember, they told you it's a quadratic. 7 minus 5, that's a 2. 9 minus 7, a 2, 11, that's a 2. As you can see, on the second difference, that's where we have truly, it's a common difference that we have there. And under a quadratic, 2a, remember our quadratic Tn is equal to an squared plus bn plus c, where 2a is equal to what? The second difference, which is 2. So you can have the value of a there, divide by 2, divide by 2. So that's a is equal to what? To a 1. What about the value of b? We're going to take 3a. So 3a before a plus b, which is equal to 5. Take the 3 to the other side. It'll be a minus there. So meaning to say b is equal to what? 5 minus 3, which is 2. All right, so we have the value of a, the value of b. To find the value of c, we equate the first term a plus b plus c. It must be equal to that value that we are given, which is what? Which is a 4. But in this case, we calculated these values. Remember, a is 1, b is 2, so plus c is equal to 4. So let's add up 1, 2, which is 3. So meaning to say we're going to simply subtract a 3 there. So c is equal to 1. So Tn, if it is a quadratic, it was going to be an squared, which is 1n squared. So it's just going to be n squared plus bn, our b, which is 2. So that's 2n plus c, which is 1. But what happened? They simply factorized this. So factorize. All right? Because we have a quadratic there. So you're going to factorize. Since the coefficient of n squared there is 1, just going to have 2 brackets. That's n and n. Remember the products up to positive 2, 1. So there is 1 and 1, minus 1 and minus 1. But when you add these numbers, which one is going to give you a positive 2? That's for a 1 and a 1. That's plus 1, plus 1. As we can see, guys, the 2 brackets are the same. So it means what? N plus 1 squared. Like I said before, 2 being squared. I mean, 1 bracket multiplying each other can be referred to as a square. So it was just a quadratic, guys, that you can use. And with this, you can even substitute those values that we had before, and you see that they are actually corresponding to what you had in this. On question number 4.2, an athlete runs along a straight road. His distance from fixed point P on the road is measured at different times, all right? N time in seconds, distance in meters, 1, 2, 3, 4, and so on and so on. The distance 17, 10, 5, and so on and so on. So it is giving us this rule. As we can see, the rule that we have there is what? Is a quadratic. They're simply telling us that if we are to simplify, we're going to obtain a quadratic. So the question is, what are the distances recorded in the table below? Okay, the distances are these ones. Determine the values of R and S. This is where we have R and what? And S. So since it's a quadratic, guys, this table, it simply shows you like the term. So you're given the terms there. That is what you're given. You're given like these are terms. Like the first term is 17. The second one is 10, 5, and so on. 5, 2, followed by R, followed by S, like that. So since we can see that it's a quadratic, because we already displayed an squared plus bn plus c, that's a quadratic. How are you going to obtain or simplify under a quadratic? Remember, there's a part of what? The first differences. Let's work with that. You were supposed to obtain what? The first difference, isn't it? 10 minus 17, which is minus 7. 5 minus 10, which is minus 5. 2 minus 5, R minus 2, if you want S minus that one, or you can just leave it like that. You work out what? The second difference is here. Minus 5, minus 7 like this. So it was going to be a plus, which gives us a 2. Same thing, minus 3, minus what? A minus 5. So it was going to be a plus and it gives us a difference of 2. So if there's a difference of 2, it means also here there was going to be a difference of 2, a difference of 2, a difference of 2. So you can even find these terms which are following to say, okay, if there's a difference of 2, guys, minus 3 plus 2 is what? If you add these two, minus 3 plus 2 is what? That's a minus 1. Minus 1 plus 2 is what? Minus 1 plus, you add a 2 to, which is what? Which is a 1. These are the numbers that we have in this second row. But as we need R and S on the top there, so let's go back to the top. We have to add again. So what are you supposed to do? 2 plus what? Minus 1. 2 plus minus 1. What do we have? 2 plus minus 1. That's a 1. So if R is 1, to find S, we add again. 1 plus 1 is what? It's S. So we have to add 1 plus 1, which is 2. So 1 plus 1 is what? Is 2. So meaning to say our R is 1, our S is 2. So we just get to like a reverse of how you simplify your quadratic pattern. Remember how you simplify your quadratic pattern, guys? So this one, it's a reverse of that. It is just a reverse of that. Then determine the value B and C are on the format dn, the dn that we are given. All right, so this was 4.21. All right, so on 4.22, given as an squared. So we're supposed to find it from this quadrant to find the value of a. Remember our second difference, which is what? Which is 2. So from our second difference, 2a is equal to 2. Guys, we are still back to our quadratic. So what is the value of a? After that, we have to find what the value of b. Remember that 3a plus b must be equal to what? A minus 7. So what is the value of what? Of b. If a is 1, we calculated a. So that will be 3 there. We take it to the other side. So b is equal to minus 7 minus 3. We take the 3 there, it becomes a minus. So b was going to be a minus 10. Having a, b to find plus b plus c must be equal to 17. Where we have these values, what is our a? That's 1 plus b, which is minus 10, plus c, that's equal to 17. 1 plus 9 plus c is equal to 17. We take the minus 9 to the other side, it becomes a positive there. So meaning to say c is equal to 17 plus 9, which is 26. So these are the values of a, b, and c. To form this quadratic that you are given, this dn that you are given. So it's going to be 1n squared, which is n squared b, just like this. All right, so this is it, guys, your a, your b, and your c. Then from there, they want you to determine how far is the antlet from P when n is equal to 8. You are given the value of n. So remember your dn, the distance is given if you substitute these values of a, b, and c. This is how our dn is going to be like at the end. So this was just a matter of substitution into the formula d8. When it is 8, in place of what? N, you're going to substitute 8. So that's 8 squared minus 10 times 8 plus 26. So that was going to give us 10. And they told us the distance is what? In meters for a time being in seconds. So this is in meters. So that's 10 meters. All right. So there we are also 4.24 that that is Michaela claims that the pattern will have a minimum value. Then Jack claims that the pattern will not have a minimum value. Who is correct? By just looking into this question, guys, it was not even a part of calculation one. By just looking into this calculation, we can see that this is supposed to have a minimum value. Remember, from our functions, this is a quadratic. So on a quadratic function, we expect to have something like this. This is the coefficient of n squared is 1. It's a smiley shape. So when our shape is like this, when it is having minimum, if it has a negative there, it is going to be like this. Therefore, it must have what? A maximum. It must have a maximum value. So having this a here, being a 1 like this, having this shape, it must have a minimum value, guys. So that's one thing that we can tell from our function. Then we can calculate that to tell if that minimum value can be calculated. Remember, at the minimum value, if you are given, let's say it's f of x, which is equal to, at the minimum value, you use the value that x is equal to minus b over 2a. It is the same thing, but now we are calculating, we're talking about n at minimum value, not x. It's in terms of n, not x. So N at the minimum value must be equal to minus B over 2A, which can be calculated minus, remember, A, this is our B, this is our C. So it's minus B over 2A, minus B. Our B is what? Minus 10 over 2 times A, which is 2 times A, which is 1. So that was going to give us negative, negative, which is a positive. That's a 5. So as we can see, our N is equal to 5, and our N is supposed to be a greater than 0, meaning to say that's where we talk of what? Being minimum value. So that's a minimum value. So meaning to say this guy is correct. The one who says it's a minimum value, Mikhaila, claims that it has a minimum value. So that is the one who is correct there. That is question number 4. On question number 4, you have to be just careful with your questions. How are they given in your simplifications? All right, let's consider question number 5, which is another part, very, very important, finance. They were given, question is worth a third of its original price, meaning to say, after 2 years, the amount is going to be equal to a third of the principal, which is the original price. Use the reducing balance method to calculate the annual rate of depreciation. What would be the annual rate of depreciation using the reducing balance method? So that is what you're given. Remember, on our reducing balance method, that the amount is equal to P into 1 minus I to the exponent of N. So the amount is a third of the principal. So that is a third of P is equal to P into 1 minus I to the exponent of N. The number of years is 2. So you'll be like, you're working with a question where not like that. We can see that the P and the P is common. These two can cancel. So meaning to say we are going to have a third is equal to this. So it will be just at this stage, a third is equal to 1 minus I to the exponent of a 2 like this. Introduce what? The square root. There's a square there. So you have to introduce the square root. We introduce the square root both sides. So by introducing the square root, we are getting rid of what? Of the square. So I like this. And this is the square root of what? Of 1 over 3. So we want to find the I there. We can take it to the other side. It becomes a positive there. So meaning to say I is going to be, we take 1 over the square root, this one, the square, this other side. So it is going to be 1 minus the square root of 1 over 3. Knowing that I is a percentage, so whatever that you're going to have here must be multiplied by what? By 100%. The rate that you're talking about there is a percentage, guys. It's a percentage. So whatever that we are going to have multiplied by what? By 100%. So remember, we fixed our calculator to 2 decimal places before. So that's 1 minus the square root of 1 over 3, like this. All right. Okay, let's move this one aside. Then whatever that you're going to have here multiplied by what? By 100%. So that was going to give us 42.26, as we can see. That's 42.26% as a decimal percent, as a percentage, like this is what you're going to have there. All right, so that is depreciation, this and that, guys. Remember, the amount is going to reduce, but we are not even given that amount. But according to the information, you can even tell what is happening and calculate from that way. 5.2, we are given Cow's car wash is saving for a new equipment invests. Okay, let's see, guys, what's happening here. He invests 10,000 at 7.5% per annum, compounded monthly. It is compounded monthly, meaning to say you're talking of 12 complete months. 5.21, calculate the effective interest rate. All right, so guys, the effective interest rate, remember the one that you're given, it becomes your nominal effective that you are given. So as we need the effective, that is the one that we need. And what are we given? The nominal is the one that we have, which is 7.5%. percent as a decimal, guys. All right, let's go back to our relationship between the effective. Remember, 1 plus I effective is equal to 1. All right, so we're just going to have a bracket 1 plus like this. So you can use the letter K, you can use N, you can use whatever letter that you want, but this is just for the compounding that you are using there. So this is being compounded what? Monthly, so that'll be 12. So meaning to say if is equal to 1 plus, the nominal is the one that you're given as a decimal, 0.075 over N, which is the compounding. So we said a 12, remember, we said it's being compounded monthly. So that's a 12 to the exponent of what? Of a 12 also. As you can see, the N here is the same one. To the other side, it becomes a negative there. So that's effective is going to be 1 plus 0.075 over 12, 1. So you're going to simplify this, whatever that you're going to obtain, whatever that you're going to obtain from this, you must multiply it by 100% because that is must be given I effective, a comma. It was actually going to be 0.0776 and so on. So it was going to be 7.76 percent. Right? So these are your basics, guys, of your, so that's your basic marks for that. And they were given 5.22. Cow deposited 10,000 at the end of the first year. All right, sorry, he deposited 10,000. At the end of the first year, the interest rate changes to 7.8 compounded quarterly. 6 months later, Cow deposited a further 5,000. All right. So we need to understand what is happening here. If Carl requires 17,000 for the new equipment, will he have sufficient funds to this purchase after 3 years? So all this must happen in 3 years. Okay. So under 3 years, what happened? Let's try to be careful. 10,000, okay, at this rate. But it only affected, or this only happened for 1 year because after the first year, the interest had to change. So remember, it's compound interest. So amount is equal to 10,000. Remember, principal into 1 plus I to the exponent of n. That's our amount. So this was still at 7, could be 0.075. But there's a compounding that we are given there of what? Monthly for 1 year. So we divide by that compounding of 12. Then the number of years we are going to multiply by 12. So it was supposed to be what? 12 times 1. It's 1 year supposed to be like this, 1 times or 12 times 1. 1 year times 12 for the compounding. So 1 times 12, guys, is just going to remain as what? As a 12. Because they are saying after that first year, meaning to say it affected the whole year. Still with the 10,000 that he deposited, only the interest is the one that changed. So we are going to need what is for this interest still on that same 10,000, but when the interest is now what? 7.8. So it's going to be 1 plus 0.078 if you divide by 100. But they are saying compounded what? Quarterly. Meaning to say you divide. Remember, interest, you divide by that. Quarterly, you divide by 4. What about the years now? How many years after the first year? So meaning to say the remaining after, within these 3 years, what is remaining? Because we have covered the first year. So it's 3 minus 1. We're talking about what? 2 years remaining. These 2 years are to be compounded quarterly. So it's 2 times what? 2 times 4. All right. And 2 times 4 is going to give us what? It's going to be 8. So that's where we are having the 8 from the 2 years compounded quarterly. So 2 times 4. All right. Then what happened? 6 months later, after the investment of that we had, like the year period. 6 months later, guys, it's 1 year. 6 months, like in terms of years, it's 0.5. It's a half year. So it's called 0.5 years. So remember, we have covered 1 year. Then we cover 0.5 for these ones. So what are we going to have, guys, from there? 1 plus 0.5, which is 1.5. So out of 3 years, how many years are remaining? If we talk of 6 months later, it will be 3 minus 1,5, which is 1,5. So we are remaining with 1,5 years, 1.5 years. So in those years that are remaining, 1,5, a deposit must be added. It's no longer part of what was happening here. It's another investment. So it's plus 5,000. The only thing that we are not told there is about the interest. It never changed after that later arrangement. So the interest will still remain at what? At 78%. So that is going to be 5,000 into 1 plus interest 0,078 over what? They are saying compounded quarterly change. So it's over 4. What about the number of years that are remaining for this money to what? To increase, to have its interest? We are remaining with 1.5 years. So that's 1,5 years times the compounding of what? Of a 4. Compounding quarterly times a 4. So that was going to give us 6. 1,5 times 4 was going to give us a 6 at the end. All right. Each and every part that you're given. So it was an interesting question. You had to figure out, guys, what is happening. So you calculate everything at once. You can calculate this, then add to this one. You can just use a calculator to calculate everything. Take note there, it's a product. And this has to be added. There is addition. All right. Sorry there. I put this one by mistake. Just hope, guys, it's not going to affect my class. This software is, guys, once you just put something that is not part of your class, it's just going to, let's see. All right. So that's it, guys. 18,191,03. All right. Remember, money to 2 decimal places. So this is what he's going to have in his account. So the question was, will he have sufficient funds? He wants to have 17,000. What is he having in his bank account? 18,000. So is it sufficient? Yes, it is sufficient. So he will have sufficient funds in the bank. All right. So that's how some of the questions are given as, guys. You just have to be careful. Finance, I wonder you guys will be saying finance is difficult, but you say finance is you just have to understand like the grammar, the English part, guys. Okay. It's not that much. Let's move on to another part. On question 5.3, 2 friends receive an amount of 6,000 each to invest for a period of 5 years. Both they have to invest for a period of 5 years. They invest the money as follows. All right, so we've got the first one, Mevin, 8.5%, simple interest. At the end of 5 years, Mevin will receive a bonus of exactly 5% of the 8% per annum compounded quarterly. That's a compound interest. Who will receive or who will have a larger investment after 5 years? Who is going to have a larger investment after 5 years? All right, justify your answer with appropriate calculations. So what can we do, guys? Let's start with Mevin. What is it that we have on this guy called Mevin? If he to invest, if he has to invest at a simple interest, remember that the amount is equal to P into 1 plus IN. That's a simple interest. Remember, I told simple interest. But there's a bonus there, plus a bonus. So you have to add a bonus. So the principal is the same amount. They both invested 6,000, all right, into 1 plus the interest as a decimal divide by 100. That's 0,085 times the number of years for 5 years. This is not going to change. What about his bonus? The bonus for Mevin is say is gonna receive a bonus exactly. Take note, guys. The statement is exactly given there. They said exactly 5% of the principal amount. Exactly 5%. So that's 5%. 5 over 100 of what? The principal amount, which is 6,000. So 5% of that is the bonus. So this is the bonus that he has to obtain. So what will be the total amount at the end? All right. So simplifying this, the first part here of the accumulated amount was going to be 8,550. You were going to obtain a total accumulated amount of 8,850, including the bonus inside. This is for Mevin. All right, let's move on to the other guy, which is compound interest, as we are given. Compounded quarterly, that's a compound interest that we are given there, where we do understand that the amount is equal to P into 1 plus I to the exponent of N. They both invested 6,000. So the 6,000 into 1 plus what is the interest rate? The interest for Hell is what? 8% compounded quarterly. So divide by 100, that's 0, 0.08 over what? Over a 4 compounded quarter. The number of years, 5 times is given there. So that was it, guys. If you simplify this, 5 times 4 is simply a 20. So you can use your calculator. Direct, that was going to give you 8,915.682. We can compare which one is having a bigger value, which one is having a larger value. So comparing these two, we can see that 8,915 is bigger than 8,850. So therefore, meaning to say that the guy called Ale was gonna have a larger investment at the end. We will have a larger investment compared to what? To the other one after 5 years. After 5 years. Remember, it was a comparison between these two. Who is going to have the bigger amount at the end? You just have to work out with the conditions that are being given. With those conditions, you play around with the information that you are given. That was actually going to help to answer that question or the part that we had there. So if you are to consider question number 6, you are given f of x is equal to a b to the exponent of x, where a is not equal to 0, and you're also given the point p. So this is our function that we are given, our exponential function there. So let's consider our first question, 6.1. Write down the domain of f. So that is a 1 mark that we are given, the domain. So remember that the domain, we are simply referring to the limiting values of x. As x is to be taken, how is it limited? The value of x, how is it limited? So x being an exponent, it is not limited of any value. It can be any value that we think of that we can substitute there. Any value that we can think of can represent x. All right. So meaning to say, in this case, we can simply talk of any real values. All right. So the x is just gonna represent any real value that we have there. Then write down the equation of the asymptote of f. The asymptote, as we can see, we do not have anything that is added to that f of x. We do not have anything that is being added to this value. So it's just like a 0 there. So meaning to say, that is going to affect our asymptote. The y value is going to be at 0. So meaning to say, we're talking of what? The x-axis is limited in the x-axis where y is equal to what? Where y is equal to 0, and being also a real number, this y that you're talking about. Then if b is 3/4 on question 6.3, they are giving you a certain value to use, 3/4. Calculate the value of a. All right, so we just need to substitute this b in place of b. Remember, that's our f of x that we are given there. So that's 6.3. So instead, we can just write as y is equal to. All right, so that's a times. Remember, they are saying if b is 3/4. So meaning to say, in place of b, we can substitute 3/4. So that's 3/4 to the exponent of x. This is what they're saying. Calculate the value of a. So where can we obtain the value of a? We need to substitute a point which consists of x and also consists of a y value. So we have a point p which lies on this function. So you can take that into consideration where we've got the x and the y value. So let's substitute when y is 144. So meaning to say 144 is equal to a. into 3 over 4 to the exponent of x, and x at that moment is what? Is a 2. So we can determine the value of a from there. We can divide by this. We can simplify 3 over 4 squared. That is going to give us 9 over 16. So that's 9 over 16 times a. Divide by 9 over 16 this side. We are going to obtain the value of a, which is 256. So that is the value of a that you're going to have, guys. So meaning to say, in this whole simplification that we had, this f of x was going to be taken as a, which is 256. Remember, our b there, they said, is 3 over 4 to the exponent of x. So this was going to be our function. All right, so that's it, guys. Our a is 256. Then moving on to the other question. The graph of g is obtained by reflecting f in the y-axis. Write down the equation of g. If we are to reflect in the x-axis, all right, in the y-axis, sorry, this is in the y-axis, we obtain the graph of g. So what is going to be the presentation of the graph of gx? From the f of x that you're given, a reflection in the y-axis, it, remember from your grade 9 mathematics, you had this, the xy is going to change the rule, is going to be given as minus xy like this. A reflection in the y-x, y is not affected. It is x, which is going to be affected by a negative. So in place of x, just multiply by a negative. So it simply means gx is equal to f of minus x. F of minus x, that is a reflection in the y-axis. The x values will be multiplied by a negative. So it's going to be 256. 3 over 4 to the exponent of minus x. So the x there is going to be replaced with a negative. All right, so that's it, guys. As we consider our exponents, remember, to the exponent of a negative, you can also interchange the bracket a over b to the exponent of a negative 1. It is same as b over a to the exponent of a 1. So meaning to say we can interchange and remove the negative. So that's the gx also could have been written as 256. That will be 4 over 3 to the exponent of a positive x. You can also have it written that way. That's a reflection that we are seeing. Let's consider 6.5. It's a question, is g an increasing or decreasing function? It's a question that you're being given about g. Is that g that you have an increasing? Give reason for your answer. So if you do not, x is equal to 0 here when x is equal to 1, when x is equal to 2, and see how the values are they corresponding. As x is increasing, are the values of y going to increase? So you're going to see that they will be increasing these values. For each and every x value that you input there, y is going to increase. So 6.5 there, the g of x is an increasing function. That's an increasing function. Right? So this is what I'm trying to say. Let's have our calculator, because some of us might be wondering, where is it? Where is this one coming from? This is 250 inside before. We can input with the negative. We can also input the one that is a positive. That one, guys, is up to you. So 256 into 3 over 4 like this. All right, so the one with the negative, let's start with the negative. Let's say x is 1. Gonna have a negative 1. All right, that's 31.341,33. Okay, 341. Okay, let's move on to, let's put 2 there and see. 400. As you can see, guys, we started with 1, it was 2, 3. These values, they are also increasing. The y values, look, they're increasing. We put a 3 there. If this is a 3, you can see that the y value is increasing 600. So as the x values are increasing, the y values are also increasing. So that's an increasing function, that one. So meaning to say, that's an increasing function. As if x increases, we have that a condition where x increases, the g of x also increases. Remember, you're comparing the function of g as we are given there. So gx also increases as we have this consideration. So that's the idea there. The same for all values of x. All right, so I'm just going to take this equation, then write it on top there was where we have these two functions. Remember, we're comparing f there, or I can just even write it here. It's not even a problem. Let's our f of x, it was after substituting, we got 256 into 3 over 4 to the exponent of x. This is f of x. So the question is prove that f of x is squared if you square this f of x, all right? That is 56 3 over 4 to the exponent of x like this. They say we are supposed to square it like this, all right? Minus f of minus x. F of minus x is just substituting a minus where x is. We put a minus. So that's 256. 256. 3 over 4 means in place of x, you substitute a minus x. But there is what? A squared there. So we are supposed to square it just like the previous case. You square this. They are saying this must be 2x. Remember, a is what? From our simplification, this is our a, this is our b, this is our x. So our a is 256. They are saying it is equal to a, which is 256. F of 2x. F of 2x, what does it mean? F of 2x means in place of f of x that we have, we are going to substitute 2x where x is. So it is going to be like this. 256 plus where x, that is what it means, f of 2x in place of x. All right, so we move on. Minus a, that is minus, remember a is 256. So that in place of it's just going to remain 3 over 4 to the exponent of minus 2x, that is f of what? F of minus 2x. So they are saying we are supposed to prove that these two are equal. If we are to simplify the left-hand side and we also simplify the right-hand side, we must have the same answer. All right, let's see. There is a squared here. So meaning to say the 256 is going to be raised to the exponent of 2. And there is an exponent. So it is going to be 256 to the exponent of 2. All right. Then the 3 over 4 is going to be, you multiply. Remember, there's an exponent, you multiply the same thing as 256 to the exponent of 2. Exponent, you multiply the 2. So that's 3 over 4 like this to the exponent of, this is our left-hand side. Let's move on to the right-hand side and simplify. There is a bracket, so it's just a matter of expanding the bracket there. So it's just 256 times 256 there. So that will be, part is just going to remain as it is, 3 over 4 to the exponent of 2x. All right, the same thing, if you expand this bracket, minus 256 multiplies that, that's minus 256 squared. So this part remains as it is, which is 3 over 4 to the exponent of minus 2x. All right, so looking in the left-hand side is exactly the same thing as what we have on the right-hand side. So in this case, that's exactly our left-hand side is equal to the right-hand side. That these two are the same by substitution of that information that you were given there. All right, not wasting our time, let's consider question 7. F of x is given, and from this f of x, 7.1 asymptotes of f. All right, remember your asymptotes there from x plus 1. From x plus 4, we can have the value of x. X plus 4 must be equal to 0. So x is equal to minus 4 by solving for x. And another one as it is, which is y is equal to what? Minus 1. That's we have our asymptotes. 7.2, calculate the intercepts of the graph of f with the x's. Meaning to say we need the x-intercept and also the y-intercept. So from our f of x, which was given as 2 over x plus 4 minus 1. All right, let's consider the x-intercept. For the x-intercept, we know that y is equal to 0. So 2 over x plus 4 minus 1, we solve for x. Minus 1 to the other side becomes a positive. That's 1 is equal to 2 over x plus 4. This is the same as over 1, so you can just simply cross multiply there. 1 multiplies everything that we have. That's x plus 4 is equal to 1 times 2, which is the other side. It becomes a negative 2. So thus we've got the x-intercept in that condition. For the y-intercept, it is just a mere substitution of x being equal to 0, just like what we had before. So y is equal to what? In place of x, you can use your calculator direct. 2 over 4 minus 1, that's a minus half. So we have the y-intercept. All right, so that's it. Then from there, sketch and intercepts with the x's. So we need to show this. All right, so let's start first. Remember, this was on the asymptotes. We have this x minus 4 and also our x-intercepts, y-intercept, this and that, all right? So remember, this is part of our x-intercept, which is x is what? X is minus 2. The y-intercept, y is minus half, all right? So I'm just going to use this space, guys. Remember, this was your 7.2, so 7.3. Just going to utilize this space. Going to have, let's say we've got our y-intercept. Also, we've got our x-intercept, our x-axis, sorry, x-axis, and the y-axis. That's a 0. Okay, let's just 1 plus 1, minus 2, minus 3, minus 4, minus 5, minus 1, minus 2, minus 3, 1, 2, 3, 4. Let's just say we've got something like this. All right, let's just say this is what we have. You're going to notice that we need the asymptotes first. Remember our asymptotes, x being minus 4 and y being minus 1. This is the major part. Our graph is limited there. X minus 4. This is where we are going to have our line of x is equal to minus 5 minus 1 in the y-axis. All right, so that's the line of y is equal to minus 1. So with this limit, we are given the x-intercept at minus 2. All right, and the y-intercept at minus half. So minus half, let's just say it's somewhere there. That's where we have our minus half in between 0 and minus 1. So our graph or our function was going to be limited in this region, all right, to the minus half of the y-intercept. Limited, it's asymptote. It cannot pass the minus 4. Remember, it's an asymptote. So we have a function in this side, on this side, and another one was going to be found on this other region. As we can see, you'll be having another graph there, which we do not have anything to relate or to mark there. Just leave it like that. So that's your sketch, guys. Your y-axis, your x-axis, then your asymptotes, the major points indicated. Then write down the coordinates of the image on question number 7.4. We need the image of the x-intercept if it is reflected about the axis of symmetry. If it is reflected about the axis of what? Symmetry of this line, y. The x-intercept. This is our x-intercept, guys. The point minus 2, 0. Remember, that's our x-intercept. They're saying if it is reflected along the line, y is equal to minus x minus 5. Equal to minus x minus 5 is the one that has got a negative gradient. Minus x minus 5, where you can say if x is equal to 0, you're going to see y is minus 5. If y is equal to 0, x, and in the y-axis, this line was going to pass at minus 5. That's the line that you're going to actually have at the end, which is something like this, passing through the intercept of what, I mean, the intersection of what? Of our asymptotes, something like this. All right. This is the mirror line. This is our question. This is our mirror line. This is our mirror line, as we are to consider this point to be reflected along this mirror line. So if you check, guys, your memo there, it was something else, because if this is to be reflected along this mirror line of y is equal to my point, the x-intercept is the one that you want to reflect this one, which is at minus 2. So it can move straight to the mirror line. It forms a 90 degrees on the other region. There is going to be seen on the other region. So you guys to say, okay, it's going to go this side down, then it was going to be difficult to say how many units is it even going this side and how many. So the easiest part that you can use is to follow this other way, to use this way. You move to the mirror line this way. How many units to the mirror line? 1, 2, 3. We are at the mirror line there at minus 5. So we have moved 3 units. 1, 2, 3. we must also move 3 units going down. So it's going to be -1, -2, -3. So the point will correspond at -3. Here it will be there, meaning to say it will correspond with the -5 and -3 according to this movement of this line. So that's why I'm saying there, according to your memo, guys, we're supposed to correct this. Actual movement of the image point was supposed to be at -5, -3. All right. So do not just take as your memo, guys. You just see the answer. They just, okay, this is the answer. Just take it. No, analyze also a concept. The mirror line concept, this was going, even if you use this graphically, you draw it on the graph, you're going to see the point is going to be at -5, -3. Okay. Even if you use any basics of your reflection, guys, let's be correct in terms of our calculations. All right. Then write down the range of this. The range of y is equal to minus f of x. Remember your f of x. This is our f of x. So minus f of x is just multiplying this by negative. So this is going to be multiplied by negative. It becomes a positive one. So if it is a positive one, it means our range has been affected to such an extent. Remember, if you're dealing with a hyperbola, that y cannot be equal to the asymptote. Y cannot be equal to 1. Remember, they said minus f of x, so you multiply by negative first. If it was for f of x, which is at -1, y cannot be equal to -1. But there they said of minus f of x. All right, so it was a straightforward question. Describe in ways the transformation that was a +2 and a +4. So meaning to say that's a reflection that you're talking about there in the y-axis. The x is being affected. Guys, our x was supposed to be a positive like this, all right? Let's see. I want you to see how it was supposed to be like. If you take out this negative, it's going to be negative what? This is x, all right, -1. We have taken the negative on 2. We want to remain with the original function. Then we multiply with that negative. Remember the negative, you can multiply it here, all right? We multiply it here. So it was going to be like this, 2 over what? Negative times x, that's negative x. Negative times -1. So as we can see, our gx from the f of x that we had, original f of x, remember original f of x, it was 2 over what? X plus 4. Part that changed is the part of x. Here, the part of x. X, it was positive. Now it's a minus. Remember, I talked about this transformation, guys, where y is given as f of minus x. This is a reflection in the y-axis. This one is a reflection in the x-axis, where the y values are the ones that are affected. Here is the x value, which is being affected by a negative. So that's a reflection in the y-axis. Like I said, x is one that is affected. So it's a reflection in the y-axis, the opposite one. Okay, so that is what you need in that case. If you understand this, it was just going to be a basic question. This one. All right, on question number 8, we are given the sketched below is a parabola J and a straight line K, which is having this equation. Then this is the information. T is the turning point. So we've got T here, which is our turning point. J cast the y-axis at y is equal to 6. That's our y-intercept. The x-axis at r, which is the x-axis at -1. And at q, we do not know the value there at q. Then J and the straight line intersect at P and Q. So P and Q, these are the points where we have the intersection. Okay, then V is a point on J and W is a point on K, such that VW is a parallel to the y-axis, meaning to say VW is a vertical line that we are seeing parallel to the y-axis, meaning to say we're talking about the points there. These two are at the same x value in this case. That's a vertical line, meaning to say we're talking about what? Same x value. The value of x there is the same that we have. All right, we're going to talk about that later. So that's our question 8.6. J can be written in this form, Jx. All right, so let's see. All right, where we have our J, this is our J, and let's consider they were given a turning point and the y-intercept. So what is the best way of writing the equation when you're given a turning point? Remember writing the equation of a parabola. There are so many ways, guys, that you can actually have this. But where you are given a turning point, you can write in the form of y is equal to a into x minus p squared plus q, where the turning point. So in this case, our turning point is 1,8. So as you can see, here it's positive, but on the formula, it's minus p. Here it's p, here minus p. So meaning to say y is equal to a into x minus this one. So that's x minus 1 squared plus q. Q is not affected. Q remains as it is, meaning say 8 remains as it is. All right, we have substituted the turning point. So what can we do now? Is there another point that is given? Yes, there's the y-intercept. Remember, the y-intercept is the point is 0, 6. So we have the x value. So 6 is equal to a into x. X is what? X, that's a 0 there. So that's 0 minus 1 squared plus 8. So let's solve for a. We can solve for a in that case. Take the 8 to the other side. It becomes a minus. Is equal to a. 0 minus 1 squared on your calculator, that's a 1. So meaning to say 1a is equal to minus 2 simply means that a is equal to what? A is equal to minus 2. So if a is minus 2, I is equal to a. In place of a here, let's substitute a minus 2. So that's minus 2 into x minus 1 squared plus 8. Remember your expansion of brackets, guys. There you just have to expand your brackets. You've got 2 brackets that you need, or you can use your basic theorems of expanding brackets. This was going to give us x squared minus 2x plus 1. All right, plus 8 on the other hand. Expand the bracket by the negative 2. Give us negative 2 expands everything. So that's negative 2 times x squared. Negative 2x squared times this. That's a positive. Negative 2 times 1. That's negative 2 plus 8. We have that's minus 2x squared. All right, there we're going to remain with positive 4x. Minus 2 plus 8, same as 8 minus 2, which is a positive 6. So that's it, guys. As we can see, that's our equation. Proved that our jx can be written in that manner. So this is how our questions sometimes are given, as you just have to be very careful in your presentation. Then calculus is what? Substitute your values, guys. This is average gradient of what? Of j. All right. It is found on j between the x points, which is x is 1, and x, which is 3. But on the function of what? Of j. Remember, this is your jx as we have. So just substitute when x is 1, what is the corresponding value in place of x? That's minus 2 times 1 squared plus 4 times 1 plus 6. You substitute. That was going to give us 8. Substitute a 3, that's a j3. In place of x, minus 2 times 3 squared plus 4 times 3 plus 6. That was going to give us a 0 there. So meaning to say we have got the values of that we are given. So we are going to substitute because these are points that you are given. So we've got 2 points. That's one, y is 8. So we are going to use that as a point. The first point, that's 1, 8. And the second one, that is when x is 3, y is what? Y is 0 there. So we're going to use the second point for gradient as we have our points. So remember, this is your x1, y1. This is our x2, y2, where the gradient is the change in y over the change in x. So that's substituting the values that we are given. In place of y, just substitute that's 0 minus 8. Then x2, which is 3, minus x1. X1 there, that's a 1. So we've got 0 minus 8 over 3 minus 1. So that was going to give us a minus 8 over 2, which is minus 4. All right, from the points that we are given. So simply we can just substitute those points and determine your gradient. So for 3 marks, guys, this was just a straightforward question, and determined it's on what? On j. So you substitute into the function of j. All right, on question 8.3, calculate the coordinates of P, the intersection. All right, the coordinates of P, they need P there. The intersection of J and K. So on the 3 that we had there, remember the other value was 3, 0. That's why they do not want you to calculate this one. They want you to focus on what? On P. But it's still the idea, guys, on calculating the point of intersection is not going to change. It is not going to change. At the point of intersection, we understand that these two, 8.3, we can simply consider that. That's at the point of intersection. The function of jx is equal to the function of kx. So remember your j 6 must be equal to kx. Remember your kx, this is the one that we had here, a third of x minus 1. So these two must be equal. It's an equation that you have formed. And that's a quadratic. Other terms of the equation to the other side so that we remain with a 0 on one side of the equation. So that's it. We're going to have minus 2x squared 4x minus a third because you're taking this side. So it will be minus 1 over 3. 4 minus 1 over 3, which was going to give us 11 over 3x. The same thing, we take the minus 1 to the other side, it becomes a positive. So it will be plus 1. See, we have our normal quantity to this fraction. So you can even use 1, this is 1. So what is 1, 3, 1, 3? Each and every term on this equation that you see must be multiplied by 3. Minus 2 times 3, that's a minus 6. So that's minus 6x squared. The 3 and the 3 here, that's 11. So it was going to be 11x. Okay, 7 times 3, that's a 21, is equal to 0. Then you can solve this equation. You can avoid working with the negative. Negative, this will be positive 6x squared, positive negative, that's a negative, positive negative, that's a negative. That's equal to 0 there. Then you can solve this. Most of it is a certain number, a 2, a 3, a 6. It becomes a challenge for you to use factorization method. If you know that you have a challenge of that, just use a quadratic formula because you have this, what you need there are the x values. So using quadratic formula, this is your a, this is your b, this is your c. Remember, x is equal to what? Minus b plus or minus the square root of b squared, which is minus 11 squared, minus 4 times a, which is 6 times c, which is minus 21. Everything over what? Or you can simply, guys, with a 3 or another value, our x was going to be minus 7 over 6. But remember, the question needs us to find the coordinate cannot be 3 because so P must be a negative. So P must be a negative. P cannot be this 3. P can only be is minus 7 over 6. Remember, we need the coordinate. So we need to find the value of y. By substituting minus 7 over 6 in any of these, you can substitute into the straight line. You can say whatever that you want there. So a third of x, remember our x is minus 7 over 6. Minus 7 over 6 minus 1 like this. It was going to give us minus. So that's minus 25 over 18. Minus 25 over 18 as a point like this. So these are the, that's the coordinates of what? Of P. So questions can be like that. If you can find or calculate W, the maximum length. Remember, at the maximum value, by completing of the square method, you can determine the maximum value. But if you check where the VW is, this is where we have the VW here. In order for you to have the length of VW, you must define the difference between those points that you are given in that case. The difference, that is the one that you're going to need. So meaning to say, in our difference there on 8.4 VW, what is the difference between the function that is j on top? This is our j, remember, which was 4x plus 6, all right? Then we subtract the w. The w lies on what? This part of the k that you're given there. This is the function of kx. So it's just the difference. This is your kx. So you need the difference. So you're going to subtract a third of x minus 1. All right, so let's subtract this. That's the length VW. So this was going to give us minus 2x squared. And expand by negative here. That's a negative, which is negative 1 over 3x. Negative here, that was going to be a positive 1. All right, so this is where we are, and we need our quadratic expression. Let's consider the like terms. All right, so you're going to need the like terms. 4x minus a third x. These are like terms, so it's just 4 minus a third. 4 minus 1 over 3. That is the difference that we are having there. So it was going to give us 11 over 3x. Then 6 and 1, you add, that's a 7. So remember, your completing of the square method gives us the maximum value if we are given a in the form of x minus p squared plus q. You know that pq is the point at the maximum value. Remember, it is from the completing of the square method, that format that you are seeing there. So you need to complete the square. So how do we complete the square? Remember, your completing of the square method, always the coefficient of x squared must be a positive. this x squared. So as you can see, there's a -2. So what can we do? Factor it out, this -2. So it's going to be -2. We divide -2, divide by -2, that will be positive. 11/3, divide to this negative, you divide. So it will be -11/6x. So it will be -7/2. You're going to need the half, the coefficient of x being squared. Remember, I talked about completing of the square method, guys. So I'm not going to waste much time there. We need half the coefficient of x being squared. Half of the coefficient of x, which is this one, -11/6. Then you have to square it. So what is that you're going to have? Half of this, that will be -11/12 squared. Yes, you can square that. It's up to you, that simplification. Or you can just substitute as it is here. So that square, we are going to add that into our quadratic expression. So it will be x squared like this. We add the square plus -11/12 squared. So as to neutralize our question, we must subtract it again, -11 squared. We add, we also subtract it. All right, then we write as it is there, -7/2. So I've talked about this, guys. You can watch the video on the completing of the square method. I think I've explained much about this on separate videos so that you can at least understand, guys. So that will give us a -2 there. Then we factorize. So this part, x squared, up to here, up to this point, you factorize it. So you take x and the -11/12 squared. We have factorized this. What is remaining, combine it from the minus this one up to this one. Use your calculator there, combine that. That was going to give us over 144 like this. All right, let's expand by -2. Let's expand by -2. What are we going to have here? Bracket. So it'll be -2 into the bracket of x -11/12 squared. Okay, we cannot multiply it inside because no, because of this squared that we see here, this one. So it's going to give us positive 625/72. So it was going to give us a positive there. So like I was saying, the completing of the square method gives us the coordinates of the turning point to say at the turning point, we have got our x as minus, in fact, it's going to be positive. Remember this? So it was like this. It was 11/12, 625/72. This is what we had as your turning point. At the turning point, that's where we have the maximum value. This is the maximum value. So if this is the maximum value, the value of y, when we substitute this 11/12, and you get a maximum value of 625/72. Therefore, that is the distance that we're talking about. Between those both, it was the distance between V and W. So the maximum length would be from what? 8,68. This is in units. So it can be like that. You just have to be very, very careful. Length, as you are to consider length, completing of the square, to consider the maximum values there. Completing of the square method. So they wanted you to use that. In most cases, they want you to use that completing of the square method. Anyways, from that simplification, now they want you to use the graphs to determine the value of values of x, for which j is increasing. We want a condition where j increases. Where are we finding j having an increase? We can see that the graph of j here, all right, that's 8.5. Well, let's analyze our graph and see what was happening throughout. This graph, as we are to consider from going up to the down, from the x is what? It's 1. So all these values there below 1, all these values comparing to x when it is 1 here, all these values going there. This function is going to be increasing. I mean, from this condition going up, it is increasing, going up. In all those values, which values are we talking about? The values that are less than 1 compared to the x value at the turning point. All these values. So we can say our x there must be less than 1. We can compare it from what? From the turning point. Our x must be less than 1, where x is an element of real values. Then where do we have an or equal to 0? All right, 8.52. So there we must be careful with our graph because they're saying, let me just try to say that we can see our question properly. They say minus j of x headed less than or negative values then, less than 0, negative values. So in order for you to have your answer as a negative, guys, it means these two functions can be positive at the same time. Remember, a negative times a positive gives you a negative, or they can be negative and negative at the same time. It cannot happen that one of it is positive, another one is negative. No, they're either positive at the same time. So that when they are multiplied by this negative, they will give us what? A negative value. Unless if this negative was there, we are going to say positive, negative to give us a negative. But because of that negative that is positive, or both functions being negative, you're going to see that from R there, here, from the point R there at -1, here at R here. Going this side, J and K are in the negative. They're in the negative region. Look properly there. But from this R going this side, J is on positive. Look, it's on the positive region. Where x-axis here, that's the negative region. So we cannot take that. No, we cannot use that. From Q, this one is in the positive. This one is in the negative. It is not like that because of this negative. So the memo there was something else. It was not supposed to be in between 0 and 3. No. This region that they are talking about, one is supposed to be positive, another also positive. Both they are supposed to be positive, or both are supposed to be negative. So it can only be these values that here. So our x values can be, or they are supposed to be less than -1. But since there's an equal to that is there, we can say less than or equal to -1. That can make sense. That can actually make sense, this one. Simplification, because somewhere you're using this and your memo will be writing something else. All right. For each value, or for each values of k will jx minus k equal to 0 have two distinct roots, in which case that they have two distinct roots, two different roots. So if we check, guys, this is the j and that other one is k, and they're saying jx minus kx. They said it's distinct roots. All right. So you can even take it, guys, as where we have different roots. Where we have what? The difference between these two. That is, maybe the line was here, the line was here, the line was, it is in between values from the turning point there. That's where we are limited. Because at the have one solution where x is 1. But for them to be distinct, these are values that are less than the turning point. Because at the turning point, there's only one solution there. But as you go down the turning point, guys, you'll be having, so you're going to compare it with the value at the turning point, the value of y at the turning point. So in this case, guys, it's just going to be a direct question. At the turning point, k is supposed to be less than 1, supposed to be less than 8. Working from where? From the turning point. So some of these questions, guys, you have to be careful with the question that you are given, analyzing of the question. More question papers that can actually help understand these typical questions that you might be given. You just have to do as many questions as you can. All right, let's consider question number 9. We are given that Jeremy enters the quiz show, Who Wants to Be a Millionaire? The objective is to answer consecutive questions correctly in order to win 1 million rand. A contestant ends when the question is answered incorrectly. Once it is incorrect, no more answering of any other question. And also, contestants may choose to answer the questions themselves or use a lifeline for assistance. A lifeline may only be used once, and it must be used within the first 3 rounds of the questions. It can only be used once and within the first 3 rounds. So there's a lot of information there that is being said that you need to understand. Anyways, they say on the first attempt, this is the first attempt, the probability that Jeremy answers the question correctly on his own, 0.7, incorrectly, 0.1, uses a lifeline, 0, 2. So this is a single branch as we add 0, 1 plus 0, 7 plus 0, 1 plus 0, 2 branch. Then if your M uses a lifeline, the probability that the lifeline produces the correct answer is 0, 9. Where he uses what? A lifeline. The correct answer will be 0, 9. 9.1 to represent the given information for 2 rounds of questions. For 2 rounds of questions. All right. So for 2 rounds of questions, this is it, guys. Let's try to analyze it here. Let's say this person is going to have a correct answer is the one that is needed. So it can be correct, incorrect, or can use a lifeline. This is what we have on the first choice. It can be correct, it can be incorrect, or using what? A lifeline. The probability of being correct, it's 0, 7 as we are given. The incorrect, that's 0, 1. And the lifeline is 0, 2. This is the first part that can happen. And it is used once. And once you use that, having what? A correct answer from a lifeline. The probability of having, meaning to say you can have a correct answer and you can also have an incorrect answer from there. So having a correct one, it's 0, 9. What about being incorrect? Remember, the whole tree is supposed to add up to 1. So you subtract 1 minus this 0, 9. That was going to give us 0, 1. So that's correct. So this is the first tree that you're going to have. Let's consider what's going to happen later on. On the second part, if he answers and gets a correct one, it means he can proceed. Remember, the contestant 10 ends when a question is answered incorrectly, meaning to say if he answers correctly, he can as well continue to use that. He can continue to use that. So once it's correct, he can continue using as it was before. It can answer. From there, he can use it can use a lifeline. But knowing that once we use a lifeline, it does not change. The probability will be correct or incorrect. So a lifeline is always like that, correct or incorrect. These values, they are not changing. Remember, these are fixed. The probability being correct, it's what? It's 0, 7, 0, 2. The probability of that and being incorrect, just like this one, it's 0, 1. So this is how it was going to be on the second part because you are correct. So it is a continuation from that value, which is correct. It is going to continue from that. All right. So let's see, guys, this software is, okay, let's just see, guys. So, all right. So everything is just it's just been affected. So I'm just gonna try and we have this, let's just have our question again. Everything has been affected as we can see, but anyways, it's not a problem. Like I was saying, you're going to need 3 branches, correct, incorrect, and the lifeline as we had. All right, let's just hope we're gonna win here. Now these softwares, guys, sometimes they can tend to be like that. So this is correct, incorrect, then the lifeline. And we saw that the lifeline can produce correct and incorrect. All right, so meaning to say the correct, it was 0, 7, incorrect 0, 1, 0, 2. Then from the lifeline, I said 0, 9, being correct, incorrect will be 0, 1. All right, so this is what we had, and this was the first branch, the first tree. Then the second one, when being correct, you have a chance again to perform because you had a correct one. So meaning to say there, you have another chance to perform correct, incorrect, or the lifeline. All right. And the lifeline is going to have correct and what? Incorrect. So this one is just a repetition of what we had. 0, 7, 0, 1, 0, 2, the correct 0, 9 when you are using the lifeline, remember. So after, if you consider the incorrect one, it cannot have a branch because once you have an incorrect answer, you're told that it ends, your turn ends when a question is answered what? Incorrectly. So you do not have another chance to have another question. All right. Then what about the lifeline? Because this is about being correct. Being correct, there's no limit because the lifeline we are being told is going to be used in its own period, that it is used once. So if you use the lifeline in the first part here and you get your correct answer, it means this correct can proceed. All right, this correct because it's correct, but this one for incorrect, you do not proceed. Once you get an incorrect answer, you do not proceed. But this one, because it's correct, it can proceed. That's another part. Having what? If it was correct, it was supposed to give us, this is the branch, a normal branch for correct. It was supposed to be like this. But remember now that the lifeline is used once. So no matter what you're going to have after this lifeline, you are going to be considering either to be correct or to be incorrect. We are not going to have another lifeline again because we're supposed to have a branch like this with correct, incorrect lifeline. But we cannot have that. We are back to the normal appeal, to the normal asking of question where the correct is what? Where the correct is 0.7. The incorrect is what? Is 0.1. But we no longer have the lifeline. The chances of having a lifeline are no longer there. That is how it was just going to be like, this is what they wanted you to have. And from there, they want you now to determine the probability that Jeremy will unassisted answer the first two questions correctly. Unassisted. That means there's no assistance. There is no need of the lifeline. The lifeline is the one for assistance. So if there's no assistance, he just get these questions correct by himself. That is what they are saying there. So it's going to be probability of correct. So the first one to be correct, it's 0.7. He answers the second one and being correct again without any assistance of the lifeline. That is one. All right. Then Jeremy answers the first question correctly. So he can answer this question, but the first correctly questions, like the first question correctly, the probability actually can be, he can just get it by himself direct. He can just get it by himself. Probability of being correct, just like by himself. Or it can be a condition that he got it correct through what? Through a lifeline, because it can be correct from where? From a lifeline. That's another condition that we can have by himself. So it's going to be probability. So what is the probability of being correct? Using lifeline and being correct at the same time. So guys, I think for our grade 10 mathematics, so that we, 7, doing a revision, but we need to work out as much questions of probability, not for exam, but basics that can actually help, because there's a lot in this probability, guys. So that was an A and B, and we are given that independent events, the probability of A and B must be equal to the probability of A times the probability of B. That is what you're given also for B and C. What is it about exclusive? So the 0. Let's have this 10.11. Calculate the probability that the following events occurring, both A and C occur. Both C, as I have stated, that there's nothing on the intersection because we are told mutually exclusive. So A and C, that's a 0 there. There's nothing. 1, 2, and C are what? B. We see the probability of C, just like probability of A times probability of B. Where we are given that probability of B is what? We are given that. The probability of B is there. The 0.4, 0.2, 0.8 on our calculators. All right, that's the B and C. Then the probability that at least A or B occurs, at least A or B, the probability of A or laws, the probability of A or B is given from the probability of A plus the probability of B minus the probability of A and B. Remember, this is the basic rule that we are supposed to consider as we are to work with our, if we are to work where the probability of A or B is equal to the probability of A. What is the probability of A? That's 0.3. The bit of B, A and B. Do we have that? We do not have A and B. But remember, we said A and B is going to be taken from A times B. because they are in it. What is the probability of A? 0.3 times the probability of B, which is 0.4. The product of those two, 0.3 and that 0.4 that we have. We are supposed to have their product. That was going to be that because 1, 2, 1, 2. So that was going to give us that it was going to be 0.58. All right, so that was it, guys, for 4 marks. It can be like that. In 10.2, you're now given this information. These are learners, and they are 108. The total learners that we are given, they are 103, sorry. Grade 11 learners were asked to indicate whether meal, chicken, fish, vegetables. The following information, this is the information that we are given, these vegetables, and this one for only in everything for us, but the X is here. This is the one that we want to calculate. So how can we obtain the value of X? We can simply subtract these numbers from the total of 103. We subtract all these, the 3, the 65, the 5, the 5, the 10, and the 2 that we are given like this. So that's our X 28, and the D to be a 5. All right, random, it's any 2 of the given, and where we have 2 or more, any 2, 2 or more. This is the part of 2 or more. This is the part of what? 2 or more. So you have to add all this. Remember, this was 5, 2 or more. So it can be 3 also, 2 or more. Any 2 means 2 or more. It's not like we are given to say it is gonna be exactly. We have 2 and the 10. This is where we have exactly 2. But here they just said any 2, it can be 2 or more. It's just like at least 2, at least 2. So the probability there, you're going to take the 5 representing X, this other 5, the 10, and 103 because they said any 2. So even 385 as a decimal to try to understand your questions as much as you can. Given this on 10.3, we're given this is the length of 80 worms in centimeters recorded in the table. So as you can see, it's like 0 to 5, 5 to 10, this and that. Determine centimeters shorter. 5 centimeters shorter, it means it's in between 0 and 5. It's less than 5. That means we're talking about this 9. And that's another one. And the other is longer than 15 centimeters, meaning to say bigger than 15. This is 10 to 15, but if we check here, 15 to 20, all this is bigger than 15, this one. From here, from this region going there, it's greater than, it's more than 15. So you talk about this 7 and the 8. So you have to add 7 plus, meaning to say the probability there was simply going to be given from these two. 9, okay, the first choice, it can be 9 out of the totality times, we take the second one in this other, it's another interval. There are 2 intervals different. It's another one, this one, which has got what? 25. But we are picking from another interval where we have picked from this one, and we're now picking another. So the total is going to be affected. So it's like without replacement. So it's going to be 79. They were 80 before. So we have removed 1. They are now 79. So you're going to multiply this by another. We're going to add another one starting with 25, but simply 2 intervals. It's just like this, guys. It's like we've got red, yellow. Then we have another one, red, yellow. And we have another one, red, yellow, like this. We need where there is, or we can have as yellow, red. So there will be 2 events that are just exchanging these numbers, but same thing. So you can simply multiply by 2. Or instead of multiplying by 2, you can add another one, starting with the last one that we had of 25. It will be 25 out of the total 80 times 9 out of. So I don't know which one. Do you understand? Just 1 times 2, or you take this one, you interchange like that. That was going to give us the probability, which is 45 out of 632. As a decimal, it was going to approximate to 0.07 to 2 decimal places, something like that. So this is how some of these questions are given, as we just have to revise as much questions as we can. That can actually help as you are preparing yourselves for the exams that are ahead of time. Just make sure that you work out as many questions as you can, go through the introductions, go through the question papers that can actually help in your revisions.